Hello, my name is Eric Brandsburg, CTO of Heimdall Data. In our previous video, we demonstrated how to install Heimdall into a WordPress environment. In this video, we will be showing the resulting performance improvement gained from this install. We will begin with the configuration installed in the previous video, although we have stripped out any unnecessary configurations to avoid confusion. As a first step, we are going to change the caching to use the local-only caching for simplicity. This option leverages the local in-heap cache and is ideal for use in single active server installs, as is typical with WordPress. In clustered server installations, it would be recommended to use a full-fledged grid cache, as invalidations and cached objects can then be shared between nodes. Next, we will want to check that the WordPress database configuration is set up correctly. As Heimdall leverages JDBC behind the scenes to connect to the database, you will want to double check that the data source configuration parameters are as shown and that WordPress is configured to use the UTF-8 or UTF-8 MB4 character set in the WordPress configuration file. Failure to configure these parameters may result in slower than expected performance or page rendering issues. Finally, we will want to verify that the WordPress virtual database is configured to point to the appropriate rule list and that the rule list is properly configured. In our list, we have disabled the logging option, as while useful for analyzing traffic, it does add additional processing latency. For production installs, it is recommended that the logging be disabled or use the match limit option with a reasonably low value to limit the impact of logging on production performance. With the rules in place, we will start the benchmark by temporarily disabling the rule list, which will disable caching. Next, we will move to start the test, which is using the wget spider function to crawl the full content of the WordPress install. We will time how long each spider run takes across several passes without caching. As Java warms up and self-optimizes, we will want to run several passes to get a better feel for how it performs over time. While we wait for the runs to complete, we can monitor the performance observed by Heimdall on the dashboard. We can see that without caching, WordPress generates about 600 queries per second and takes an average of just over 600 microseconds per query. Now that several benchmark runs have completed, we can see the baseline performance is about 2 minutes 20 seconds per run, plus or minus. From prior testing, this value is the same or slightly lower than if Heimdall was not in place at all, as any performance overhead is offset by the use of connection pooling within Heimdall. Now that we have our baseline, we can enable caching and observe the results. Again, we will want to allow the test to run several times and monitor the progress on the dashboard. Here we can see that almost immediately we achieve an 80% cache hit rate. This is due to how WordPress operates. Like many applications, WordPress uses the database as a configuration source and performs the same queries on page views over and over. Only a small portion of the queries are specific to the pages being viewed, and this results in a high cache hit rate almost immediately. Now that we have allowed the benchmark to operate long enough, it has entered a phase where the same content is being retrieved a second time, which allows the hit rate to go from 80% to 100%. We can now also see the full impact of caching on the per query performance. Prior to enabling caching, our response time was just over 600 microseconds. Now, the average response time is under 50 microseconds, and the queries per second has increased from 600 to 900 per second. Finally, we can now take a look at the final benchmark numbers for our cache runs. Prior to enabling caching, each run was about 2 minutes 20 seconds. Now, with caching enabled, this has been reduced to 1 minute 20 seconds or less, or about 75% improvement in page views per second. This benchmark of WordPress is unusual in that we were able to achieve a 100% cache hit rate. However, it is typical to find that applications can achieve at least a 50 to 80% hit rate and can improve response times by 30 to 50%, even if the application is already using caching internally. Most developers do not use the advanced techniques leveraged by Heimdall to determine what should be cached and to automatically invalidate responses, and as such, caching is at best suboptimal. The use of Heimdall can improve performance and reduce database load without any code changes, and as shown, can even improve third-party applications.